Welcome back to another exciting calculation in chemistry. Now this question said, what is the mass of impurity in a sample of calcium carbonate if 0.060 mole of carbon 4 oxide was formed when 8.0 grams of the sample reacted with excess dilute hydrochloric acid? The equation for the reaction is given by calcium carbonate reacting with hydrochloric acid to produce calcium chloride plus carbon 4 oxide plus water. Now if you observe critically, you see that this is a neutralization reaction, right? So in a neutralization reaction, a base reacts with an acid to form salt, water, and giving out gas, which is what? Carbon 4 oxide here. Alright, so let's walk through the question again. Now the question says, what is the mass? So we're going to be looking for mass of impurity, right? Now we know that mass of impurity is equals to the moles of the impurity times molar mass, right? Of which sample? They say, what is the mass of impurity in a sample of this? If this carbon 4 oxide, so we're going to be looking for the mass of impurity in this, right? So we look for molar mass of calcium what? Carbonate, right? So this molar mass of what? Calcium what? Carbonate. So the moles of impurities in calcium carbonate, right? So okay, so let's see how we go about this. Now first and foremost, let's bring our equation. CaCO3 solid reacting with hydrochloric acid aqueous to produce calcium chloride aqueous plus carbon 4 oxide gas plus H2O liquid. Alright, now what is their ratio? You see that this is 1:1, right? 1:1. Okay, so if that's that, what is the relative atomic mass of calcium carbonate? We know that calcium has one atom here, and that's just what? 40. The atomic mass is 40. Then carbon has one atom as well, and the atomic mass is 12. Oxygen has what? 3 atoms, and the atomic mass is 16 times 3. So this will be giving us 40 plus 12 plus 16 times 3 give 48. So this amounts to what? 100 grams. Okay, so if that's the relative atomic mass, then let's now start relating it in our question. Now we know that this 1 mole, right, of calcium carbonate produced what? 1 mole of carbon 4 oxide. So it also means that 100 grams of carbon 4 oxide also produce what? Okay, let me even include the compound. Produced what? 1 mole of what? Carbon 4 oxide, right? Okay, so if that's that, now looking at the question, they say which of this was formed using what? 8.0 gram of the sample. So it means now if 100 gram produces 1 mole, then 8.0 gram will produce what? X. Remember that our method, so we cross multiply. So X times 100 will give 100X. 8 times 1 mole will give you what? 8 mole. So let's divide both sides by 100 to find our X. So this cancels this, and X is equals to what? 0.08 what? Mole. Alright, so this is the mole that we've gotten, and this mole is of what? Carbon 4 oxide. Right? So now what it means is we have gotten the number of moles of carbon 4 oxide that will be formed when 8 grams of this sample is used, right? From 100. Now, how do you proceed? They said there is an impurity of 0.060 mole, right? So if you go back to this first equation that I wrote here, it says mass of impurity is equals to what? Moles of impurity, which is this, times molar mass of calcium carbonate. We already know our molar mass to be what? 100 what? Grams, right? That's correct. We've calculated it. What about the moles of impurity? So let's find the moles of impurity now. Moles of impurity of calcium carbonate will then be equal to what? 0.08 minus 0.060. So that will give you what? 0.02 mole. So we have gotten this value to be what? 0.02, right? So mass of impurity now. Mass of impurity of what? Calcium carbonate will give you what? 0.02 times 100 grams. So that gives us what? 2 grams. So that is the mass of impurity of calcium carbonate when we have impurities of 0.06 mole of calcium carbonate formed when 8 grams of the sample reacted with excess dilute hydrochloric acid in this equation. So this brings us to the end of this calculation. It's nice having you around and following from start to finish. I really need to appreciate your efforts, and I will see you in other videos. Bye for now.